All right, here we go. I have the full unit circle. I'm going to start with the degrees. I start here, 0 degrees, then 30, 45, 60, 90, and then we just continue with that pattern. 120, 135, 150, 180, and then add another 30 to that, so 210, add 15 to that, to 25, and then add another 15 to 40, and then add another 30, so 270, and then add another 30, so 300, then 15, 315, then add another 15, 330, and then add another 30, 360. Cool. And then for the radians, we're going to go 0. Good job, guys. Pi over 6, pi over 4, pi over 3. We got to know those, right? And then this one's pi over 2. And then this one right here is going to be, what do you think? 2 pi over. Perfect. What's the next one? And what's the next one after that? Yep. And then we got 2 pi. And then this one is. And what's the next one? And the next one? Yep. And then this one here is 3 pi over 2. And then this one here? Yep. And then 4, what's. And then this one's 6, what's the top? There you go. And then one full revolution, 2 pi. And then the coordinates. So the radius is 1, so this one's 1, 0. Then this one's square root of 3 over 2, comma 1/2. So the x gets smaller while the y is getting larger. And then here, both of them are square root of 2 over 2. And then this one's going to be 1/2, and with a square root of 3 over 2. And then here's where this is 0, and that's a 1, right? And then on the quadrant 2, what's negative? The x's, square root of 3 over 2, negative square root of 2 over 2, square root of 2 over 2, and negative square root of 3 over 2, comma 1/2, and then negative 1, 0. And then in quadrant 3, both are negative. Negative square root of 3 over 2, negative 1/2, negative square root of 2 over 2, negative square root of 2 over 2, negative 1/2, negative square root of 3 over 2, and then 0, negative 1. And then in quadrant 4, the x's are positive and the y's are negative. 1/2, negative square root of 3 over 2, square root of 2 over 2, negative square root of 2 over 2, and square root of 3 over 2, negative 1/2. And there it is. That's all of them. How do we feel? Okay. Let's go to the next one. So number 2 says, find the point on the xy on the unit circle that corresponds to the angle negative 5 pi over 6. So negative 5 pi over 6 looks like this. You're going to go, and there it is. That is negative 5 pi over 6. So you're rotating the same amount as 5 pi over 6. 5 pi over 6 would have been there, see? So you rotate the same amount, but in the positive, in the negative direction. The negative direction is clockwise. No. Well... it might work, but I recommend that you just rotate like this. You know what I mean? Does that make sense? Okay. So that's the best route in my opinion. So negative, negative. So negative square root of 3 over 2, negative half. That's the answer. All right. Next one says, which of the following values of theta satisfies the equation where cosine is negative square root of 3 over 2? So I come to the unit circle again, and I look for where cosine is negative. Cosine's the x value, so I see it in quadrant 3 here and in quadrant 2. So I'm looking for that. Notice that the denominators are 6's. So here we go. Let's see. That one, yep. Nope. And nope. So just number 1. Do you see how we did it? Okay. Let's go to the next one. Which of the following pairs of trig ratios are equivalent? Well, tan of pi over 4 is 1. See, because it's both the x and the y are the same. So it says tan of pi over 4, and it says tan of 5 pi over 6. Yep, that's going to be 1 as well, because they're both negative. Negative divided by negative is a positive. So that one works. So I'm going to put check mark, check mark. Pi over 6 and 4 pi over 3. Well, they don't even have the same denominator, so that means the magnitudes are going to be different. That one's out. And then look, pi over 6 and 7 pi over 6. Yep. Pi over 6, 1/2 over square root of 3 over 2. That's 1 over square root of 3. And 7 pi over 6, negative 1/2 divided by negative square root of 3 over 2. That's again going to be negative 1 over square root of 3. Or, sorry, positive. 1 over square root of 3. Negative divided by negative is a positive. And look, 1/2 divided by square root of 3 over 2. Again, that's going to be 1 over square root of 3. So there it is. So it's going to be 1 and 3. So 1 and 3. Do you see how we did it? Okay, for sure, or are you just saying that? We got it? Okay. On this one here, it wants to know. Oh, we ready for the next page? Yeah, I did. On one of them, I did for like this one, I did negative 1/2 divided by negative square root of 3 over 2, which reduces to a 1 over square root of 3. And on this one, I did 1/2 divided by square root of 3 over 2, which again is the same thing, 1 over square root of 3. See how that's the same? And same thing with this. This is a 1, and this was negative square root of 2 over 2 over negative square root of 2 over 2, which is again a 1. Because negative divided by negative is a positive. You know what I mean? Okay. All right, this next one here. Which of the following angles theta is such that sine theta is a negative half? So I'm going to look on my unit circle where sine is negative. It's in quadrant 3 and 4. And I see this one, and I see this one. So notice that the denominator is a 6. Later, Rudabaso. So I'm looking for a denominator of 6. So let's see. 7 pi over 6, yes. Pi over 3, no. Negative pi over 6, yeah, that's a 1. Because if I go clockwise right here, that's the same thing as 11 pi over 6. See? Cool, right? So that's a 1. That's the answer. So 7 pi over 6 and negative pi over 6. So 1 and 3. How do we feel? Okay. 135 degrees. So 135 degrees is the one in the middle of quadrant 2. So the x is negative square root of 2 over 2, and the y is square root of 2 over 2. Okay. So cosine of negative 135, negative square root of 2 over 2. Sine of 135, square root of 2 over 2. Tan of 135 is y divided by x, so square root of 2 over 2 divided by negative square root of 2 over 2, so a negative 1. No, don't do that. It's just y divided by x. Yeah, it's 1 because the magnitude is the same. Well, it's negative 1. Positive divided by negative. What's up, Lopez? No, Valderas would. Or Ms. Wiersberg. Secant of 135 is just the reciprocal of this. So 2 over, or negative in the front, square root of 2. You can leave it like that. Or you can go negative 2 square root of 2 over 2, and the 2's cancel out. So another answer, you could just say negative square root of 2. You know what I mean? Cosecant is the reciprocal of sine. So just 2 over square root of 2, or just square root of 2. Whichever one you like. And then cotangent is the reciprocal of tangent. So you can just tell me negative 1 again, just like that. No, it's not positive because it's x divided by y. So you would have done negative square root of 2 over 2 divided by square root of 2 over 2. So again, it's just negative 1. You see it? Say it again? Yeah, because you're just dividing the same magnitude, but one negative, one positive. So that's why you're still making negative 1. The reciprocal negative 1 is also negative. Thank you, boss. Are we understanding this, miss? Okay, good. All right, here we go. Cosine of 330. You ready for this one? So 330 degrees looks like this. It's this one right there. That coordinate is square root of 3 over 2, comma negative half. So cosine, square root of 3 over 2. Sine, negative 1/2. Tangent is y divided by x. So negative 1/2 divided by square root of 3 over 2. So you can leave it as negative 1 over square root of 3. Or you can say negative square root of 3 over 3. When you multiply the top and the bottom by square root of 3 over square root of 3. All right. Secant. Secant is the reciprocal of cosine. So 2 over square root of 3. Or you can say 2 square root of 3 over 3. They're both the same. Cosecant is the reciprocal of sine, negative 2. And then cotangent, you can just write it as negative square root of 3. Two over negative 1. No, it's not negative 2 yet. We're still okay? Okay, let's go to the next one. So this time they wanted at pi. So pi is located right here. That's negative 1, 0. So here we go. Cosine of pi, negative 1. Sine of pi, 0. Tangent of pi, that's 0 divided by negative 1, which is 0. Secant of pi. Secant of pi is the reciprocal of cosine, so the reciprocal is just negative 1 again. Cosecant of pi, it's a reciprocal of 0. The reciprocal of 0 is undefined. Undefined. You can't divide by 0. And same thing with cotangent of pi. Undefined. There it is. Cool? Okay. Let's go to the next one. So now here we can use the calculator. So it says quadrant 3, and notice it says cosine is negative 1/3. So I would have liked to have seen this, but if you didn't do that, that's fine. I would have liked to have seen a reference triangle. See, like that. And this is the angle, actually. But we're using our reference to help us out. Adjacent over hypotenuse. So here's adjacent, negative 1. Hypotenuse, 3. The hypotenuse is never negative. I need to figure out this distance there. Negative 1 squared plus y squared equals 3 squared. Are we still okay? 1 plus y squared equals 9. Move the 1 to the other side. Y squared equals 8. Square root. Y equals plus minus. This is 4 times 2, and the square root of 4 is 2. So 2 square root of 2. You don't have to. You could have left it as square root of 8. So this is negative 2 square root of 2, or you can leave it as negative square root of 8. All right, here we go. Sine, opposite over hypotenuse. Negative 2 square root of 2 over 3. Use a reference to help you out of what's opposite. Does that make sense or no? Yes. So I did, so opposite, so here's the reference. Opposite, boom, hypotenuse. So opposite over hypotenuse. So negative divided by positive is a negative. There it is. Then tangent is opposite over adjacent. Negative 2 square root of 2 divided by negative 1. Negative divided by negative is a positive. You could have also left it as square root of 8, but 2 square root of 2 is the better answer. All right, secant. Secant is the reciprocal of cosine. Negative 3. You just take the reciprocal. Cosecant is the reciprocal of sine. Negative 3 over 2 square root of 2. If you want to rationalize it, I guess you could multiply this by square root of 2 over square root of 2, and you would get negative 3 square root of 2 over 4. You don't have to. You can leave it like negative 3 over 2 square root of 2. And then negative divided by negative is a positive, so you can do 1 over 2 square root of 2, just reciprocal of this. Or multiply this by square root of 2 over square root of 2. Square root of 2 over 4. Or 1 over 2 square root of 2 if you wanted to. Or 1 over square root of 8. Ask me, miss. Yeah. Negative 1 over negative 2 square root of 2. And negative divided by negative is a positive. Does that make sense? You okay? Okay. You guys doing okay over there, guys? Okay. Sorry, I'm not listening. I'm just... All right. Next one. This is quadrant 1. See how it says cosecant is 12 over 13? So that means sine is... Did I say cosecant is 12 over 13? Cosecant is 13 over 12. So that means sine is 12 over 13. So I'm going to show quadrant 1. I'm going to go... Here's my theta. Opposite, 12, hypotenuse 13. Do you see how we did it? Okay, here we go. If I want to figure out what this x value is, you're going to go x squared plus 12 squared equals 13 squared. You don't have to, but if you already know that's 5, that's fine. X squared plus 144 equals 169. So then x squared minus 144 minus 144, 44, 54, 64. So x squared equals 25. So x equals plus minus 5 when you take the square root. So you're going to have the positive 5 because you're in quadrant 1. Does that make sense? All right, here we go. Here's the answer. No, 12 is opposite because it's a reciprocal of cosecant. So that means sine is 12 over 13. So 12 is opposite your angle. You know what I mean? Okay. Here we go. Cosine, adjacent over hypotenuse, so 5 over 13. Tangent, opposite over adjacent, so 12 over 5. Are we okay with those? All right, here we go. Secant. Secant's reciprocal cosine, 13 over 5. Here's cosecant theta, 13 over 12. That one's a given. Cotangent, so reciprocal tangent, 5 over 12. Or I guess you can say x over y. Cool? Let's go to the next one. All right, here we go. Now we're going into interesting questions here. I might need a calculator, so let me get my calculator out just in case. All right, so this is tangent. Remember, write down SOHCAHTOA first. So it says, suppose an acute angle of a right triangle and that tan theta is 2 squared root of 2 over 3. So here's you don't have to do a grid, not to scale. Do I have a phone charger? Yeah. Is it Apple? I do want an Oreo. You don't want it? Thank you.
Yes, it is. Is it the new one or the old one? The Type C? I can't tell. Oh, I don't. I use the old one.
I don't want this.
Oh, can I use that one?
Go ahead. Unplug it.
I'm going to be in Weirdsburg.
Okay.
Okay, well then run. Bye, Will.
Are you going to bring it back?
Yes, I will.
Okay. All right. Ready? Sorry. Tan is opposite over adjacent. Here's my angle. 2 squared root of 2, 3. So here's what I want to see. 3 squared plus 2 squared root of 2 squared equals r squared. Yeah. It's an acute. If it's acute, it's going to have to be in quadrant 1 because it's less than 90 degrees. Do you know what I mean? All angles in quadrant 1 are acute. It's not the scale. I mean, you could always just have drawn a triangle and done it without the grid. All right, here we go. 3 squared, 9. 2 squared root of 2. Well, 2 squared is 4, but square root of 2 times square root of 2 is 2, and 4 times 2 is 8. And then 9 plus 8 is 17. That's r squared. We still okay? So r squared equals 17. So r equals square root of 17. Okay, now we're ready. They want sine and cosine. So I'm going to go sine theta equals opposite over hypotenuse, 2 square root of 2 over square root of 17. And then I'm going to multiply this by square root of 17 over square root of 17. So you're going to get 2 square root 17 times 2 is 34. So 34 over 17. So there it is. That's what sine theta is. We're still okay? All right, let's look at cosine theta. Cosine theta is adjacent over hypotenuse. So 3 over square root of 17. We're going to rationalize it. So multiply by square root of 17 over square root of 17. And you get 3 square root of 17 over 17. Does that make sense? All right, there it is. So let's look for that. 3 square root of 17 over 17 and 2 square root of 34 over 17. It's D, no? We're okay? That's a good book, Ms. Zamora Johnson. I actually take some of those questions and put them on exams. Sometimes I do.
I'm gonna study when I go home.
Okay. You should post that on your Instagram, and then tell people get on my level or something. You know. All right. Ready for this one? It's a 30, 60, 90 triangle. In a 30, 60, 90 triangle, you have this n square root of 3, and 2n. You still okay? All right, here we go. That y value is this one. And the x value is that one. Let's see, what do they give me? AC is 9. AC. So that is your long leg. So that's 9. So, since I know that y equals n, I'm going to say y square root of 3. Well, maybe I'll just use this terminology and then I'll change it to y. N square root of 3 equals 9. So to get n by itself, you just divide by square root of 3. Divide by square root of 3, divide by square root of 3. N equals 9 over square root of 3. If you want to rationalize it, multiply this by square root of 3 over square root of 3. And you're going to get 9 square root of 3 over 3. You see what we did there? Yeah, 9 divided by 3 is 3, so that's how we got that 3 there. That one. So that's a small leg, or that's a y, so that's this one. So that is 3 square root of 3. And then how do you get the big leg? By multiplying by what? I'm sorry, not the big leg, the hypotenuse. Multiplying by 2. So I'm going to go y equals 3 square root of 3, and then x equals, just multiply 3 by 2, 6 square root of 3. Keep the square root of 3. And there it is. How do we feel? Okay, keep going. All right, so we're just going to convert these to degrees. So we're just going to multiply this by 180 over pi. So you take a calculator, and we're doing, so here we go. Here's my alpha. And I guess you don't need a calculator if you already know, like 7 pi over 6 on the unit circle, where is it at, you know? So multiply this by 180 over pi. And look, you're not shocked. 210. Put a degree symbol. You're not shocked. That's what we said right here. And the unit circle, that's what we said right there. See, 7 pi over 6 is 210 degrees. What's the other one? 3 pi over 2. That is equivalent to 270 degrees. 11 pi over 2. So take this number, multiply by 180 over pi. You're pretty close to 180 because 11 over 12, that's almost a whole pi. So let's see what that is. So I just go, and I guess you don't have to put the pi in there because you know that the pi's cancel out anyways if you just go times 180. But 11 pi over 12 times 180 over pi. 180 over pi. And like I said, maybe I'm being too, like, you don't have to go this route. There it is, 165. So 165 degrees. Make sure to put the degree symbol. Cool? All right. Which of the following statements is true about the angle theta? If theta is such that you're in quadrant 3, that's quadrant 3, then the reference angle would equal 180 minus theta. Nope. If you're in quadrant 3, so here it is, this is theta. If I go 180 minus this angle, well, that angle is bigger than 180. This would give me a negative angle. Can the reference angle be negative? So this is nope. Theta r must be positive. And by doing this, you'll make a negative angle. Number 2, if sine theta is positive, that's what this means, then angle theta can terminate in quadrant 1 or quadrant 2. Yeah, that's true. If sine theta is positive, y is positive. Those sine theta is positive in quadrant 1 and sine theta is positive in quadrant 2. So that one's true. If cosine theta is negative and tan is negative, then the angle theta will terminate in quadrant 2. So let's see. In quadrant 2, cosine theta is in fact negative, and tan, which is y divided by x, yeah, you're going to get a negative angle in quadrant 2. So there it is. So 1, 2, and 3. You see how they did it? Which of the following angles will terminate in quadrant 2? All right. 13 pi over 15. Look how close that is to a whole pi. That one is definitely going to terminate in quadrant 2. You're pretty close to a whole pi. So you could always multiply, if you wanted to, you could always multiply these by 180 over pi to see the angle. 7 pi over 5, look, that's more than a whole pi. And Chop, what are you talking about a whole pi? Why are you referencing pi so much? Well, here's 0, here's pi over 2, here's pi. I need an angle between half a pi and a whole pi. See? So I need an angle to be between half a pi and a whole pi. So that's this one. Number 2 is out. Oh, wow, look at this one. This one goes negative. That one is going to be, because I go negative, look, I'm bigger than a whole pi. So you're going to go like this, and then you're just going to go a little bit past by pi over 12. So you're going to, yeah, that's going to get you in quadrant 2. Do you guys see that? If you wanted to find out what negative 13 pi over 12 is, you can go negative 13 pi over 12 times 180 over pi. And then take your calculator and go 13 over 12 times 180. 13 over 12 times 180. And that's 195, negative 195 because it's negative. And yeah, negative 195 degrees. If I do this, I'm in quadrant 2 there. See, do you see that? So it is 1 and 3 again. So this one looks like it has a common theme there. How do we feel? All right, let's keep going. In right triangle ABC with right angle C, AB is 12, BC is 6. Find the length of the missing side. Okay, that's the key, right angle C. So I'm going to draw a right triangle. I'm going to put C. I'll put that as A, put that as B. And then they tell me that AB is 12, so AB 12, and then BC is 6. I want that side right there. So you're just going to go, if you recognize it, it's a 30, 60, 90 triangle, not to scale. If you don't recognize it, that's fine. Just go x squared plus 6 squared equals 12 squared. X squared plus 36 equals 144. Minus 36 minus 36. X squared equals 36, 46. What's that? 108. I don't know why that took so long. 36, 46. Yeah, there we go. We're good. Square root. So let's see. What gives me 108? 36 times 3? 36 times 3. There it is, 108. And what's the square root of 36? 6. 6 square root of 3. Keep the 3 inside the radical. There it is. You could have always let the answers give you the answers. If you didn't know that, you could have been like square root of 108. And then just start typing in the answers. 6 square root of 3. Oh, look, same, digit per digit. Cool, right? Okay. All right, here we go. Find the exact values of the six trigonometric functions of an angle theta in center position whose terminal side contains a point 2,3. So that is in quadrant 1, not to scale. So that means this is 2 and this is 3. So if I want to figure out what r is, 2 squared plus 3 squared equals r squared. 4 plus 9 equals r squared. 4 plus 9 is 13, so 13 equals r squared. Square root, r equals square root of 13. We're still okay? All right, here we go. Cosine. This is my angle adjacent over hypotenuse. 2 over square root of 13. Or 2 square root of 13 over 13. We're okay? All right, sine. 3 over square root of 13 or 3 square root of 13 over 13. Oh, what's up? We're okay so far? All right, tan, opposite over adjacent, 3 over 2. Cotangent, adjacent over opposite, or the reciprocal of tangent, 2 over 3. We're still okay? Cosecant, the reciprocal of sine, square root of 13 over 3. I will leave it right there like that. Secant, the reciprocal of cosine, square root of 13 over 2. How do we feel? Not bad? Okay. Last one. Name the quadrant that satisfies this condition. All right, here's my quadrants. In quadrant 1, everything is positive. Everything is positive. Everything positive. In quadrant 2, tan is negative and cosine is negative. If tan is negative, that means cotangent is negative, and if cosine is negative, that means secant is negative. The reciprocal of cosine is also negative. In quadrant 3, cosine is negative, sine is negative, but tangent is positive. Tangent is positive, cosine is negative, sine is negative. So that means everything else is negative as well. For the reciprocal of cosine is negative, the reciprocal of sine is negative. That's what I meant. No, cotangent is still positive. And okay, I guess we can stop there. So check it out. Tan's positive. Well, tan's positive right there. Cosecant's negative. Well, if sine is negative, then that means cosecant is negative because sine is the y values. See? So there it is. Cosecant's negative and tan is positive. So quadrant 3. Did that make sense? All right, there it is. We're done. How do we feel? Was this a fair test? All right, just upload the corrections to Canvas and we'll call it a day.